future tech titans, getting ready for those software engineering interviews. I bet you are. Well, today we're serving up the ultimate cheat sheet. We're doing a deep dive into this awesome blog post from Tagbee. You know Tagbee, right? It's that website with a ton of job resources and interview prep materials. This post is from February 7, 2025, and it's full of sample answers to those common interview questions. You know the ones, the technical ones that make you sweat and the behavioral ones that can totally trip you up.
Yeah, you know what I find really cool about this Tag Me guide is that it doesn't just throw the quote-unquote right answers at you. It's more about, really understanding the concepts behind those answers
Yeah.
and showing off how you solve problems, which is what really wows those interviewers.
So it's not just about like memorizing facts and figures. It's about showing them you can think on your feet and, tackle those challenges.
Exactly. It's all about proving you're not just some code monkey. You're a real problem solver.
Okay, so let's dig into this thing. Let's start with the classic tell me about yourself question. Seems easy peasy, right? But I have a feeling there's more to it than meets the eye.
Oh, absolutely. This is like your golden opportunity to make a killer first impression.
Yeah.
And you got to tailor your response, to the specific company or the role that you're going for.
Yeah.
The sample answer they give in the Tag Me post is a great place to start. It hits on all those keywords interviewers love, like computer science student, passionate, problem solving, Python, Java, apply my skills, learn and contribute.
It's like they've whipped up the perfect intro recipe.
Yeah. And notice how it mixes those technical skills with those all-important soft skills. Like being eager to learn and having a collaborative mindset. That tells the interviewer that, hey, you're not just in it for the code, you're invested in your own growth and the success of the whole team.
So it's about showing them you're well-rounded, not just some coding machine.
Exactly. All right, let's switch gears a bit and dive into the technical questions. This is where Tagbee really shines. They've got a whole section dedicated to helping you show off how fluent you are in those core concepts.
Okay, hit me with some examples. I'm ready to get technical.
Well, they've got everything from object-oriented programming to the differences between arrays and linked lists, and even a comparison of SQL and NoSQL databases.
Oh, the SQL versus NoSQL battle. That's a hot one these days.
It really is. And what's fascinating is how it reflects like the whole evolution of data management. With big data and cloud computing on the rise, companies need databases that can handle massive amounts of unstructured data. That's where NoSQL comes in. It offers that flexibility and scalability that those traditional SQL databases sometimes struggle with.
So if you can talk about these trends, it shows you're not stuck in the textbook world. You're keeping up with what's happening in the industry.
Exactly. It shows you get the real-world challenges companies face and how different technologies can solve them.
Okay, so we've talked about crafting that perfect intro and showing off your knowledge, but now it's time to face the music, the dreaded problem-solving and algorithm questions. These are the ones that can make or break an interview.
They can be scary. But honestly, interviewers are more interested in your thought process than getting the perfect answer. The Tagbee post gives some really good examples, like reversing a linked list. It walks you through the steps using an iterative approach with pointers to show a clear and systematic way of thinking.
So it's kind of like showing your work in math class. You got to prove you understand the logic, not just the final answer.
You got it. Another great example is finding the second largest number in an unsorted array. The key here is efficiency. Tagbee's solution uses two variables, max and second max, to keep track of the largest and second largest numbers as you go through the array. This makes sure you only have to go through the array once, which is super efficient.
I remember getting stuck on that one in my data structures class. It's amazing how a simple change in your approach can make the solution so much more elegant.
It really is. And speaking of efficiency, this problem brings up the whole concept of Big O notation.
Oh yeah, Big O notation. That was another question in the Tagbee guide. And honestly, it always felt kind of like a foreign language to me.
I get it. It's a way of describing how the performance of an algorithm changes as the amount of data grows. Imagine you're looking for a specific book in a library. If you have 1,000,000 books and you got to check each one by hand, that's going to take forever.
Ugh. Yeah, I'd probably give up before finding the book.
Exactly. But if you had a sorted catalog, you could narrow down your search super fast. That's kind of what Big O notation helps us do with algorithms. It tells us how much longer it takes to run an algorithm as the amount of data gets bigger.
So it's like a measure of how well an algorithm can handle tons of data, like how scalable it is.
Exactly. And that's crucial for software engineers because we deal with huge data sets all the time. We've got to make sure our code is efficient and can handle the load. Writing code that works fine for a small amount of data but crashes when you have millions of records is a recipe for disaster.
Okay, so big O notation is basically a way to check how efficient and scalable our code is. I'm starting to see why it's so important, even though it can be a bit abstract.
It's one of those fundamental concepts that helps us write better, more efficient code. Now let's dive into another cool problem from the TAGB guide, detecting a cycle in a linked list. This one can be a bit tricky, but it shows off a really clever technique.
A cycle in a linked list? How does that even happen? And how do you even start looking for it?
It's like when a linked list, instead of ending, normally has a node that points back to an earlier node. It creates a loop.
Yeah.
Like if you were walking through a maze and kept going in circles. To find these cycles, there's this really neat algorithm called Floyd's cycle detection algorithm.
Floyd's cycle detection algorithm. That sounds kind of cool. How's it work?
Imagine you have two runners, a tortoise and a hare. They both start at the beginning of the linked list. The hare moves twice as fast as the tortoise. If there's a cycle, the hare will eventually catch up to the tortoise, proving there's a loop. It's a super elegant solution that uses speed and logic to solve a complex problem.
I love that analogy. So it's not about checking each node one by one. It's about using a clever strategy to find that cycle faster.
Exactly. It shows how algorithmic thinking can lead to elegant and efficient solutions. And it shows how powerful it is to really understand data structures and algorithms.
Okay, I'm starting to feel like a real algorithm detective. We've tackled reversing linked lists, finding the second largest number, and even detecting those tricky cycles. What other problem-solving gems does TAGB have up its sleeve?
Let's get into something that makes even experienced programmers nervous: memory management. Specifically, let's talk about how to deal with memory management in a language like C++.
Ooh, memory management. I've heard it's important, but haven't really had to deal with it directly. What makes it such a big deal, and why is it so tricky?
It's a big deal because it's all about making sure our programs use memory responsibly and efficiently. In C++, you have direct control over how memory is allocated and deallocated, which is powerful, but also a big responsibility.
So it's like they hand you the keys to this super powerful machine, but they also tell you to handle it with care.
Exactly. If you're not careful, you can end up with something called memory leaks. That's when your program keeps grabbing more memory, but never lets go of it. It leads to performance issues and even crashes.
Memory leaks sound like a total nightmare. How do you avoid those?
The TAGB guide stresses how important it is to understand dynamic memory allocation. It's how you request memory from the system when you need it and give it back when you're done. It involves using the new and delete operators in C++ to control those memory blocks.
So it's like renting an apartment. You
Right.
sign a lease when you need it and give notice when you're moving out.
Perfect analogy. And just like an apartment, if you forget to give notice, you're stuck paying rent for a place you're not even using. That's basically a memory leak. But luckily, C++ now has tools like smart pointers, like unique PTR and shared PTR. These help automate memory management, making it easier to write safe and efficient code.
Ah, so smart pointers are like having a property manager. They take care of the lease and make sure everything's handled properly.
Exactly. They handle all the memory stuff behind the scenes, making your life way easier and reducing the chance of errors.
This is all so interesting. It's amazing how much thought goes into something like managing memory.
It's super important for building reliable and efficient software, especially in languages like C++, where you're directly controlling memory. And it highlights how software development is always changing. New tools and techniques are always popping up to make our lives easier and our code better.
That reminds me about how important continuous learning is. Staying up to date is key for any software engineer who wants to stay ahead of the game.
You got it. The TAGB guide even has a section on behavioral questions related to continuous learning, like how do you stay updated with new technologies? They suggest things like following tech blogs, attending webinars, and contributing to open source projects.
Those are great ways to stay involved and expand your skills. It's like being a student forever, but in a good way.
Exactly. Software engineering is dynamic and exciting, and there's always something new to learn. The TAGB guide encourages us to embrace that lifelong learning journey.
We've covered so much in this deep dive: data structures, algorithms, memory management, and the importance of continuous learning. It's amazing how it's all connected and so crucial for building awesome software.
You're absolutely right. But there's one more critical piece we got to explore: communicating your technical expertise effectively. Even if you know everything, if you can't explain it clearly and confidently in an interview, it won't matter.
So it's not just what you know, it's how you communicate it. Those soft skills are just as important as the technical ones.
Exactly. In the next part of our TAGB breakdown, we'll focus on how to nail those behavioral questions, show off your soft skills, and make a killer impression on those interviewers.
Okay, so just left off talking about those tricky behavioral questions, but before we get into that, I want to circle back to those problem-solving skills. I'm ready for round two of those algorithm questions.
You got it. Let's revisit that reversing a linked list example. I think there's more to unpack there.
I'm still kind of wrapping my head around those pointers, the previous, current, and next. It's like juggling.
I can see why it feels that way, but think of it like this. Imagine you have a playlist of songs, and you want to switch the order. That's kind of what we're doing with a linked list. Each song is a node in the list, and the pointers tell us what order they're played in. So by messing with those pointers, we can reverse the whole playlist.
Okay, that helps me picture it. So it's not just some random concept. It has real-world applications.
For sure. And what's cool is there are multiple ways to solve this. The TAGB guide shows the iterative way, but you can also do it recursively. Each method has its pros and cons, and the best one depends on the problem you're trying to solve.
So it's not about memorizing one solution. It's about analyzing the problem, weighing your options, and explaining your logic clearly.
You got it. Now let's move on to another classic, finding the second largest number in an unsorted array. This one's all about efficiency. The TAGB solution uses two variables, max and second max, to keep track of the largest and second largest numbers as you go through the array. This way, you only have to go through the array once, which is super efficient.
I remember struggling with this one in my data structures class. It's
Yeah.
crazy how a simple tweak to your approach can make the solution so much more elegant.
It really is. And speaking of efficiency, this problem touches on the whole concept of big O notation.
Oh yeah, big O notation. That was another question in the TAGB guide.
Mhm.
Honestly, it always seemed like a different language to me.
I understand. It's basically a way of describing how an algorithm's performance changes as the amount of data increases. Think of it like this. You're searching for a specific book in a giant library. If you have 1 million books and have to check each one individually, that's going to take forever.
Oh, for sure. I'd give up way before finding the book.
Exactly. But if they had a sorted catalog, you could find your book super fast. That's kind of what big O notation does for algorithms.
Yeah.
It tells us how much longer it takes for an algorithm to run as the data grows.
So it's like a way of measuring how well an algorithm can handle massive amounts of data, like how scalable it is.
Exactly. And that's super important for software engineers because we work with huge data sets all the time. We've got to make sure our code is efficient and can handle the load. Writing code that works fine for a small data set but crashes with millions of records is a big no-no.
Okay, so big O notation is like a way to check how efficient and scalable our code is. I'm starting to get why it's important, even if it seems kind of abstract.
It's a fundamental concept that helps us write better, more efficient code. Now let's look at another interesting problem from TAGB, detecting a cycle in a linked list. This one could be tricky, but it uses a clever algorithmic technique.
A cycle in a linked list. What's that? And how do you even go about finding one?
It's when a linked list, instead of ending properly, has a node that points back to an earlier node, creating a loop. Like imagine walking through a maze and you keep going in circles. To find these cycles, there's a cool algorithm called Floyd's cycle detection algorithm.
Floyd's cycle detection algorithm. That sounds interesting. How does that work?
Imagine two runners, a tortoise and a hare. Both start at the beginning of the linked list. The hare is twice as fast as the tortoise. If there's a cycle, the hare will eventually catch up to the tortoise, proving there's a loop. It's a really neat solution that uses speed and logic to solve a complex problem.
I love that analogy. It's not about brute forcing your way through every node. It's about using a smart strategy to find the cycle faster.
Exactly. It's a great example of how algorithmic thinking can lead to elegant and efficient solutions. And it shows the power of understanding those core principles of data structures and algorithms.
I feel like an algorithm detective now. We've covered reversing linked lists, finding the second largest number, and even spotting those sneaky cycles. What other problem-solving tricks does TAGB have for us?
Let's talk about something that even seasoned programmers get nervous about: memory management. More specifically, how to manage memory in a language like C++.
Memory management. Huh. I've heard it's important, but I haven't had to work with it directly yet. What's the big deal and why is it so tricky?
It's important because it's all about using memory wisely and efficiently. In C++, you have direct control over how memory is allocated and deallocated, which gives you power but also a lot of responsibility.
So it's like they give you the keys to a Ferrari, but also tell you to drive carefully?
Exactly. If you're not careful, you can run into something called memory leaks. That's when your program keeps using more and more memory but never releases it. It can cause performance issues and even crashes.
Yikes. Memory leaks sound terrible. How do you avoid those?
The TAGB guide really stresses the importance of understanding dynamic memory allocation. It's about asking the system for memory when you need it and giving it back when you're done. You use the new and delete operators in C++ to manage those chunks of memory.
So it's kind of like renting an apartment. You sign the lease when you need the place and give notice when you're moving out.
Perfect analogy.
Eek.
And just like with an apartment, if you forget to give notice, you're still paying for a place you don't live in. That's what a memory leak is like. Luckily, C++ now has these things called smart pointers, like UniGepDrawer and shared PTR. They basically help automate memory management, making it easier to write safe and efficient code.
So small pointers are like having a property manager. They handle the lease and make sure everything is taken care of.
Exactly. They take care of all that memory stuff in the background, making your life as a programmer easier and reducing those pesky errors.
This is fascinating. It's amazing how much thought goes into something like managing memory.
It's essential for building reliable and efficient software, especially in C++, where you're directly in control of memory. And it shows how the world of software development is always evolving. There are always new tools and techniques popping up to make our lives easier and our code better.
That brings us back to continuous learning. Staying up to date with new tech is so important for any software engineer who wants to stay ahead of the curve.
Absolutely. The TAGB guide even has a section on behavioral questions about continuous learning, like how do you stay updated with new technologies. They suggest things like following tech blogs, going to webinars, taking online courses, and even contributing to open source projects.
It's all about showing that you're not just showing up and doing your job, you're actively engaged in the software world and always learning.
Exactly. That passion and commitment to growth are what make you stand out from the crowd.
We've covered a ton in this deep dive: data structures, algorithms, memory management, and why continuous learning is so important. It's amazing how all these things are connected and so crucial for building great software.
You're right. But there's one more crucial piece of the puzzle: communicating your technical knowledge clearly and effectively. Even if you know everything in the world, if you can't explain it in an interview, it won't matter.
So it's not just about what you know, it's how you explain it. Those soft skills are just as important as the technical ones.
Absolutely. In the next part of our TAGD breakdown, we'll focus on nailing those behavioral questions, showing off your soft skills, and making a killer impression on those interviewers.
Welcome back to the show. All right, so we just wrapped up part 2 talking about all that technical stuff, but now it's time to shift gears and talk about those all-important soft skills. You know, the ones that can really make you stand out in an interview.
Yeah, we've spent a lot of time on those technical concepts, but let's be real for a sec. No one wants to work with a coding genius who can't communicate or collaborate right.
Totally. It's like having all the ingredients for an amazing meal, but not knowing how to cook.
Perfect analogy. And that's where this TAGB guide really comes in handy. It's packed with practical tips on how to handle those tricky behavioral questions that interviewers love to ask.
Okay, let's get specific. What are some of the most common behavioral questions we should be ready for?
Well, one of the classics is, tell me about a time you worked on a team project. It's all about figuring out how well you collaborate and communicate.
So it's not enough to just say, I'm a team player. We got to back it up with a solid example, right?
You got it.
Huh.
TAGB uses a great example of a university project where a team built a chatbot for customer support. It highlights how the team worked together, from designing the architecture to implementing natural language processing, and they made sure communication was crystal clear throughout the whole process.
That's a really strong example. It shows both the technical skills and the teamwork in action.
Right. It paints a picture of someone who can write code, but also contribute to a team. And that's what interviewers are looking for, someone who can thrive in that collaborative environment.
So it's about highlighting those times when you went above and beyond just coding and actually worked together and communicated to achieve a common goal.
Exactly. All right, let's move on to another common one. How do you handle tight deadlines? This one could be a bit stressful, but it's a perfect opportunity to show off your organizational skills and your ability to stay cool under pressure.
So how do we make sure we don't sound like we're going to freak out when the deadline is approaching?
TAGB suggests a structured approach. Break those tasks down into smaller, manageable chunks, prioritize like a pro, and use tools like Trello or other project management software to keep track of everything.
So it's like having a battle plan instead of just running around like a headless chicken.
Exactly. And if you can share a real-life example of a time you successfully met a tight deadline, it makes your answer even more believable.
Okay, so structure and real-world examples are key. What about those times when we get stuck, like, on a really tough coding problem?
Oh,
How do we talk about that in an interview?
that's where the question, describe a time you faced a coding challenge and how you solved it, comes in. This is your chance to show off your problem-solving skills and your resilience.
I bet interviewers want to know that we don't just give up when things get tough.
Absolutely. Tagby has a good example of a developer who ran into authentication problems with JWT tokens while building an API. They talked about the steps they took to debug the problem, how they researched solutions, and how they stuck with it and finally fixed it.
So it's like turning a frustrating situation into a learning experience and showing that you're not afraid to dig in and solve a problem.
Exactly. It highlights those qualities that make a great software engineer: persistence, resourcefulness, and a willingness to learn from your mistakes.
And speaking of learning, we talked earlier about staying up to date with new technologies. How can we show that dedication to continuous learning in an interview?
Well, interviewers often ask, how do you stay updated with new technologies?
Mhm.
It might seem like a simple question, but it's a chance to really stand out and show your passion for this field.
So what are some ways we can show off our love of lifelong learning?
Tagby suggests things like following tech blogs, attending webinars, taking online courses, and even contributing to open source projects.
It's all about showing them that we're not just punching the clock. We're genuinely interested in the software world and always learning new things.
You got it. It's that passion and commitment to growth that really sets you apart.
Well, we've covered a lot of ground in this deep dive into software engineering interviews, from the hardcore technical stuff to those crucial soft skills.
It's been a journey, and I hope everyone listening feels more prepared and confident about tackling those interviews.
Remember, it's not just about showing off your technical chops. It's about showing them you're a well-rounded person who can collaborate, communicate, and solve problems effectively.
And don't forget about the power of continuous learning. The world of software development is constantly changing, and embracing that change is key to a successful and fulfilling career.
So to all you future tech stars out there, go rock those interviews. And remember, the learning never stops.
Mhm.
Think about what areas of software development excite you the most and how you want to make your mark on the world. Keep those questions in mind as you start your journey. Thanks for joining us on the deep dive.